Welcome to the deep dive. Today we're looking at a pretty serious piece of enterprise hardware. It's the NTI UNIMUX-4X16-U KVM matrix switch.
Right.
And this thing has a price tag of around $3,400. So I guess our mission today is to figure out what on earth justifies that. Why does a KVM switch cost more than a pretty decent server?
Well, the key is really in that word matrix. I mean, most people now think of KVM as something that runs over the network, IP-based control.
Sure, remote desktop stuff.
Exactly. This is different. This is all physical. It's deterministic control. So when you absolutely cannot have latency, when you can't worry about network security or dropped packets, a physical matrix is, well, it's non-negotiable.
Okay, so let's unpack that a bit. The architecture. The specs say it's a 4x16 switch, but then they mentioned it can scale up to 8 users controlling up to 32 computers.
Yeah, that's a massive control ratio.
It is. So you have a handful of people who can individually or even at the same time take control of this huge bank of machines.
And that's the thing. It's built for these high-stakes environments. You might have multiple technicians who need to look at the same diagnostic screen or perform maintenance at the same time across totally different systems.
And it handles all that physical plugging.
All of it. 16 host ports, 4 user stations. And it maintains really high resolution too, 1920 by 1200. That's all packed into a standard rack mount box.
But I think the part that really made my jaw drop wasn't just the connectivity, it's the compatibility list. We're talking Windows 2000.
Right.
All the way to Windows 10, Solaris, Linux, Mac G4, and G5,
Right.
and even old SU and Blade and Fire machines. I mean, what stands out to you there? That's a huge list.
That versatility is the real aha moment. This device is basically a technical time machine. It makes sure that your critical server from, say, 2002 can still be managed from a modern console.
It's a translator.
It is a universal translator for hardware. It's compliant with old USB 1.0 and 1.1 standards. You can hot plug everything. And this is the crucial part. You can connect an ancient PS2 keyboard or an old SUN computer using special adapters. It literally bridges decades.
And you need that to be reliable. I saw the mean time between failure is something like 50,000.
Or 50,000, yeah.
The specs also mention dedicated microprocessors to keep computers from locking up. How does that actually work? What are they doing?
So they handle what's called the keep alive handshake. If you switch control away from a PC, especially an older one, it might think the keyboard and mouse just got unplugged.
And then it freezes.
And then it freezes or crashes.
Yeah.
So that little microprocessor inside the switch pretends to be the keyboard and mouse. It keeps that connection alive so the host machine never even knows you've switched away. It's that kind of deep reliability.
So with that level of complexity, I'm starting to see where the price point comes from. The management and security features must be pretty robust.
Oh, absolutely. In these kinds of environments, you need that. It has an on-screen display, an OSD for configuration. It also has an RS-232 port for out-of-band serial control, password security, and very importantly, it's TAA compliant.
TAA compliance, so that means it's approved for government use.
Exactly. That opens it up for federal contracts, for military installations, places where security and origin of manufacture are critical. Plus, it's Crestron compatible, so it can slot right into existing, very complex automation systems.
So when we put this all together, what's the big takeaway for our listeners?
I think the core lesson for you is that when you look at high-level infrastructure, the biggest challenge isn't always about speed or the newest tech. It's about reliably managing your technical debt. It's about keeping those mission-critical systems that are decades old running safely. This switch, it's a handshake across time.
So that leaves me with a final thought for you to chew on. Given that this device can bridge an ancient SUN system with a modern Windows PC, and that it's TAA compliant for government use, what kind of high-stakes industrial or, national security applications would specifically demand that level of complex, legacy-friendly, and physically durable control? Just think about the kind of places where technology from 30 years ago absolutely cannot be allowed to fail.